The world's reliance on fossil fuel-based energy is a significant issue. Irreversible environmental damage and increasing energy prices are some of the side effects of over-reliance. Small islands typically rely on fossil fuels for electricity generation and are disproportionately impacted by these issues. Small island electricity generation suffers from increased electricity costs, vulnerability to fluctuations, and a lack of security of supply.
Renewable electricity has been identified as a potential solution to the issue typical of small island electricity generation. This project aims to develop a framework to investigate the feasibility to supply 100% renewable electricity to small islands. This research applies the developed framework to a New Zealand small island as a case study, Stewart Island.
Stewart Island is the third largest island in New Zealand, located 30 kilometres off the bottom of the South Island. Stewart Island has an abundance of renewable energy resources, in particular wind and wave. Shown here are the energy resource maps around Stewart Island for both wind and wave.
Four energy resources had the best potential to supply Stewart Island with renewable electricity: onshore wind, offshore wind, wave, and solar. Offshore wind and wave resources showed significant locational variation. As such, a site selection was needed. Developing a site selection method made use of a 5-stage structure. The selected method utilizes vector normalization and analytical hierarchy process, or AHP. Vector normalization converts raw data to a common scale and direction. AHP is a structure where a decision maker performs pairwise comparison of selected criteria to develop criteria weightings and then evaluate a location to produce a numerical rating. Consistency in the criteria weighting was achieved by creating a consistency index for each site selection and limiting the maximum variation of consistency to 10%. Criteria used to select optimum location on Stewart Island were selected from literature, then filtered by the data available. So the table over here contains all the criteria used to select the site for each energy resource.
The AHP values created represent the suitability of a site for renewable electricity generation with either wave or wind energy converters. This will take into account all of the criteria previously mentioned to present the optimum location for that energy resource. These values are calculated for each location in a 1 kilometre grid on Stewart Island. The results show that the ideal locations for both offshore wind and wave was the west side of the island, directly opposite the one town on the island, Oban. 3 scenarios were considered during the criteria weighting stage: balanced, prioritising energy resource, and prioritising transmission costs. This was done to investigate the impact the decision maker's preference had on the final result. Changing the decision maker's preference hugely changed the optimum location selected. You can see here that prioritising energy resources shown in the red, decision maker's preference to all the balanced case shown in the blue and purple, and the prioritised transmission costs shown in the green, that these sites vary a lot based on what is prioritised in the criteria weighting stage. Furthermore, the greater priority the energy resource was given, the more locations that were included within the top 10% of the AHP values. Shown here are only the top 10% of the AHP values. This shows that for the case of Stewart Island, energy resource is not the limiting factor, and that there are significant trade-offs between the criteria chosen.
Exclusion criteria indicate where renewable electricity generation cannot occur. Two subcategories of exclusion were found: flexible and strict. Strict exclusions are areas where generation must not occur, and flexible where generation could occur with conditions. It was found most of onshore is excluded in some way. As such, the only viable solar and onshore wind locations is next to Oban on the east coast.
In conclusion, the best location for offshore wind and wave was found to be the west side of Stewart Island, while onshore wind and solar is best closest to Oban. Changing the focus of site selection through modifying the criteria weighting hugely influences the optimum location, demonstrating there is significant trade-off between the criteria chosen. However, given that energy resource is not the limiting factor, it is important to consider factors outside of energy resource. Should the developed framework be utilised on other small islands, such as those in the South Pacific, the relative importance of criteria is key to selecting the best location.
Thank you.
Thank you.